Today we're going to be looking at the electronics and seeing the motor controllers and the main computer board. We're going to try and trace some of the more obvious wires so we can hook them up to the new controller and to the new motor drivers. Also, while we're there, a couple of people in the comments mentioned that the existing servos are fantastic compared to stepper motors in certain instances, and they are of course right. The servos can operate a lot faster, they've got lower power. I looked up the engraving speed on this and it was, I think the head can move at 12 feet per second, which is insanely fast compared to a stepper that I'm planning on fitting, which I calculated might manage 3 feet a second. So that would be great if we could do that. Also, it seems that these servos are a lot smoother and a lot more precise, so that things like engraving, you don't get as many artifacts or lines, which I used to get a lot with my old printer. So it would be great if we could keep the servos, but I'm pretty sure the controller boards for the motors in this are analog based somehow. They don't accept a digital step pulse, which is what the new controller boards do. I have looked up, in fact somebody suggested a make of motor driver to use. Unfortunately, the cheapest I could find was like £80 second on eBay. New they are £200, which is way beyond the price of £15 or £20 I'm paying for stepper drivers. So it's not going to be used a lot. It's more of a hobbyist machine for me, so it's probably not worth investing that much money to get them working. And going with my original plan of fitting steppers is probably the best. But we're going to leave it as an option. We might find something interesting at the back, which means we can keep the current controllers. We'll see. Let's take it apart and have a look. Okay, here specifically, this is the main controller board, which looks a bit like a PC motherboard. You can see there's a RAM module on there. There's a bunch of other chips, possibly some custom chips. There's going to be a CPU somewhere. Obviously custom made for this task. There's a parallel printer port there, shows you how old the system is. Behind this are the motor drivers, so let's expose those and look at them and see if we can find out what they do. So these are the motor drivers. Brush type PWM servo amplifier. Okay. There's not many of the pins connected. Let me see if I can see which ones they are. So we've got digital direction, which makes sense, and then fault out. So that pin specifies the direction, and that pin is a fault out. So the fourth connection down is 1, 2, 3, 4, which is positive reference in, and 7, which is tack, positive tack ground. And then of course we've just got the motor positive, motor out, motor negative, and motor ground. I'm not sure how that would work. It does suggest that the logic for the positioning of the motors is actually handled by the computer board and not by these. I really don't know how they work. They connect to this connector here. We've also got a switch there. Oh, it's a fuse, 5-amp fuse. Okay. Let's trace these wires to see where they go, to see if they go to the linear positions. Okay. This connector, everything on this side is control signal and filter signals. They go into this big connector here, which is unsurprising. Everything motor output go down there, and one goes that way and the other goes that way to the power supply. So the two motors output go into there and they feed directly to the motors. They must do. There's only 4 connectors. But the motor power looks like it comes in separately and feeds into that board too, because there are some larger connectors for the motor power that comes out of there. If we separate these wiring looms, we can see what is interlock switches from around the board. We can probably find out where the sensors come into the board. We can definitely trace the power back to over there. We have got a huge 48 volt power supply, and under it what looks like a smaller switch mode, which is probably delivering something like 24 volts to this controller board, or maybe even less, because I know there's a 5 volt signal somewhere. So maybe that's supplied by the board, because I can't necessarily see. There's nothing obvious on this controller board that is a 5-volt regulator. Let's start snipping. The more I disconnected and pulled cables out of this thing, the more I realised I was probably not going to use them again. The cables are fine, but they all have connectors on the other ends where they connect to the interlock switches on the doors, for instance, and on the various other pieces. So I can easily replace them. And on the controller board side, it would mean cutting them all back. I think it'll just be easier to fit nice new cables, new connectors, and wire it up with the correct cable lengths to my new controller board. So in the end, I took everything out. This is the Z Rays. So this one here was connected to the motor, directly to the motor. It goes up here and was connected to that breakout board, which we know has a lot of control signals coming in from it. Further down here we have another cable which I can feel a micro switch. Let's see if I can see it. Let's see if I can see it. There's a micro switch just there. That obviously tells the system when the bed gets to the 0 position. And then we have another cable coming out, going to that device there. That is the air assist input. And this is some sort of solenoid valve that turns on or off the air assist. That has a separate connector on it, so if we want to replace that wire, that cable, we can. Now, up here, we have all of this bundle that come out and go round the case. And if we come round here, we can see it goes all the way up to this connector here, and hang on, let's go around the other side. So it goes all the way up here to this connector here, which we believe is the rotary attachment, don't we? However, there is a couple of small cables just there which go to that. Now I'm pretty sure that is yet another Hall effect sensor, so that it can determine if the case is open. And that is actually wired into that grey loom, I think. So now I've got a huge pile of cables, all labelled in case we need to put anything together or we need to steal one of the cables because we can't replicate the connector. But they're all pretty standard connectors, so we should be able to buy new to rewire all the major circuits. Motors and stepper drivers have arrived, so the next video will be figuring out how to mount them in the new holes. In the meantime, I am going to look up drivers for the servo motors that I've got to see if we can actually reuse them. It would be great to get that extra speed, especially on the x-axis, but we'll see.